Building a secure user registration system in Spring Boot might sound tricky. We'll set up the project, secure it with Spring Security, store user data in a database, and even add email verification for account activation. Ready? Let's get started. I'm going to start from scratch and create a brand new Spring Boot application. Let's head over to start.spring.io. Now, configure our project setup. First, I'll select the build tool as Maven, which I prefer. Next, I'm choosing Java as the programming language. For the Spring Boot version, always try to use the latest stable release. At the time of this recording, the latest version is Spring Boot 3.4.2. Now, let's update metadata. For the group name, I'll enter my domain name in reverse order, com.learnwithiftekhar. For the artifact name, I'll use auth demo, updating the name authentication application. Let's also give it a short description, simple authentication demo. For packaging, I'll keep it as jar since that's what we typically use for Spring Boot applications. And for Java version, the minimum required version is Java 17, but I'll be using Java 21. You can pick any version, 17 or higher. Next, we need to add the required dependencies. I'll click on this Add Dependencies button. If you're using Mac, you can also press Command+B, and on Windows, it's Ctrl+B. Now, let's select the necessary dependencies. First, I'll add Spring Web since we are building a web application. Next, we need Thymeleaf. We need Spring Security, which will handle authentication. We also need Spring Data JPA for database operations. For sending mail, we need JavaMailSender. I need another dependency for database driver. Since I am using PostgreSQL, I need a PostgreSQL driver. That's pretty much all the dependency that we need at this moment. Now, let's generate the project. Click on the Generate button. The project is generated and downloaded as a zip file. Let's open it in the IDE. Here, I have imported the project into my IDE. I am using IntelliJ IDE Ultimate Edition. IntelliJ IDE is my favorite tool for developing Java-based applications. I highly recommend you give it a try. This Ultimate Edition is a paid version. You can use their Community Edition, which is completely free. And honestly, their Community Edition is more than enough for most of the developers. But this paid Ultimate version obviously provides some cool and more advanced feature that helps you develop your application quickly and easily. If you want to give it a try, I have a link in the description below. By using that coupon, you will get a 3-month subscription of Ultimate Edition completely free. Back to the code. Let's start our project. Let's check the console message, expanding the console a little bit. Our application failed to start. Let's check the reason. It says, failed to configure a data source. URL attribute is not specified. So, what's happening here? Let's close the console and open our pom.xml file. Now, take a look at this dependency, Spring Data JPA. We have included it to handle database operations. However, Spring Data JPA requires a properly configured database before the application can start. Since we have added the dependency but have not configured a database yet, Spring Boot is throwing an error. To fix this for now, let's comment out this dependency. After that, we need to synchronize our Maven project. We can do this by right-click, select Maven, then click Synchronize Project. Now that the synchronization is complete, let's restart our application and see if it works. So, as you can see, our application has started successfully on port 8080. And Spring Security has also generated a password. Here it is. Let's copy it. Now, let's navigate to the application in the browser. Here, we have this login page. To log in, the default username is user. Now for the password, paste the password we have just copied from the console. Sign in. Now, we see this white label error page. Let's check the status code. It's 404. That's because we have not set up any endpoint to handle requests from the root URL. Let's fix this first. Closing the console. Now, let's expand the sidebar. Inside the base package, I am going to create a new package. Name it controller. Inside this controller, let's add a new Java class. Name it home controller. Now, let's annotate it with controller. Add a get mapping annotation to map the root URL. Then provide the URL, that is our root. Then we create a public method home, and this returns the name of the HTML file that should be rendered when the URL is accessed. Here I'll render home. Now let's create this HTML page. Inside the resources, template, create a new HTML file. Name it home.html. Here let's change the title to authentication demo. Inside the body, I am going to add some content. First, adding an H1 heading with the text welcome and a paragraph saying you have successfully logged in. Now let's start the project. Our password is generated again. Let's copy it, refresh the page. Let's enter the username, user, paste the password and sign in. And there it is. We see the text coming from our home.html file. Up until now, we have not added any custom security configurations. We have mainly used Spring Security default setup just to confirm that the necessary dependencies are in place. At this stage, the default implementation stores credentials in memory. The application does not persist the credentials, so if we restart the application, any stored credentials are lost. This approach is fine for proof of concept or quick testing, but it's not something we would use in a production-ready application. However, it serves as a great starting point. Now, let's start overriding the default security configurations. The first step is to define our own user and password. We are not yet ready to store credentials in a database and authenticate users from there. Instead, we are going to take it step by step. For now, I will use in-memory user details manager. This allows us to store credentials in memory, which Spring Security will then use to authenticate requests. Just like the default setup, in-memory user details manager is not meant for production, but it's an excellent tool for learning and testing. Let's start by creating a configuration class. First, in the root package, I am going to create a new package named config. Now, inside the package, let's create a new Java class called security config. Collapsing the sidebar for now to focus on the code. Here, we need to annotate this class with configuration to let Spring know that this is our configuration class. We also need to enable web security, so we'll use enable web security annotation. In this class, we'll override Spring Security's default configuration and provide our own. Now, we'll define our user. Spring Security uses user details service to load user-specific data. So, let's define a bean for it. Create a public method, user details service, that returns user details service. Inside this method, we'll define our user. Spring Security uses user details object to represent users. I'll create a variable named user equals user. Make sure you import user from Spring Security core package. We'll set the username to Iftikhar and provide a dummy password. Next, we need to assign a role to this user. Roles are essential when we deal with authorization. Here, we are not dealing with roles in this tutorial. For now, we will assign an arbitrary role, let's say admin, and build. Finally, we will return a new instance of in-memory user details manager and pass the user as a constructor parameter. Here, we are providing the password as a plain text, but Spring Security requires password to be encoded. If we don't use encoder, this password won't work. To fix this, we'll define another bean for the password encoder. For this example, I'll use bcrypt password encoder. Bcrypt is a widely used hashing algorithm for secure password storage. Now, let's go back to our user definition and update the password. Here, we have provided our password. Here, let's call the password encoder that we have just defined. Then, encode and provide the password. This ensures our password is securely hashed. With that, our user is ready. The final step is to update Spring Security to use our custom user configuration. We will define a new bean, public method, security filter chain. This method accepts an HTTP security object which allows us to customize security settings. Now, let's define our authorization rule for HTTP request. We'll start by authorizing HTTP request. Inside this method, we'll define the authorization rule using lambda expression. Any request must be authenticated. This rule ensures that any request to our application requires authentication. Next, we'll enable form-based login. For now, we'll stick to the default settings. We'll also enable logout functionality with the default configuration. And we need to specify user details service. We have already defined the user details bean, so we'll provide it here. This is our user details service method. Now let's build and return the HTTP security configuration. Let's start the project and see if everything works. The application has started successfully. Now let's open the browser and refresh the page. Here's our default login page. Let's provide the username and password we have defined earlier. Let me close the console. This is the username and this is our password. Back to the browser, providing the username and password. Sign in. Great. We have successfully signed in. We have just customized Spring Security to use our own credentials for signing to the application. Right now, our credentials are still stored in memory. Our next step is to store the credentials in a database and authenticate the user from there. Instead of using Spring Security's default user details service, I will create a custom user details service that will load the user's information from the database. Inside the base package, I will create a new package and name it service. Inside this service package, let's create a new Java class named custom user details service. This class needs to implement the user details service interface provided by Spring Security. This interface requires to implement a method. Let's implement it. This is the method load user by username. This load user by username method returns a user details object which Spring Security uses for authentication. Let's check the source of the user details. Here we can see that user details is an interface. We need a class that implements it. In this application, we will have user entity which will implement this interface. Let's close this file. Inside the base package, create a new package named entity. In this package, let's create a new Java class, user. This user class implements user details interface. We need to override several methods from the interface. These are the methods that need to be implemented. Let's select all. The IDE has generated the required methods for us. Now, we'll add the properties for our user class. This user is our entity. We want to map it to the database. Annotate it with entity. Here, my IDE is not showing any suggestion for the entity. Let's check. Open the pom.xml. Here, previously, we have commented out this Spring Data JPA dependency. We need to uncomment it. Now, synchronize the Maven project again. Now close the POM file. Back to the user class. Annotate it with entity. Also annotate with table. Table name users. Now, we need to define the property for the user. Since this is an entity, we need to define a primary key. For the primary key definition, we need annotation ID. Private field, type long, name is ID. Next, we need to specify how the primary key will be generated. For that, we'll use generated value annotation and set the generation strategy to generation type sequence. Finally, annotate the primary key field with column and give it a name, ID. Next, we need to add a first name field. We will annotate with column, give it the name, first name, and set nullable to false, which means this field cannot be null. Now, the user also have a couple of other properties. Let's copy this first name definition, including the column annotation, and paste it below. This time, it's for the last name. I am updating the column name to last name and changing the field name to last name. Let me scroll up a bit. I'll paste the code again. This time, it's for the username. Update the column name to username and change the field name to username. Again, I paste the code. Now, this one is for the password. Update the column name to password and set the field name to password. And finally, I need a field for email. Paste the code again and update the column name to email. Also, change the field name to email. Next, I am adding a new field to indicate whether the user is enabled or not. This field is of Boolean type and I name it enabled. By default, the user is disabled, which means they can't log in. After verifying their email address, the user gets activated and can sign into the application. Now we have these methods from the user details interface that we need to override. Let's start with the getAuthorities method. In this method, we need to provide a list of roles or privileges that a user has in the application. These roles or privileges determines which resources the user can access. Since this tutorial is focused on registration and sign-in, I am not defining any specific roles or privileges for the user. For now, any role name will work for us. Inside the getAuthorities method, we need to define a simple granted authority object. I will name it authority. Now, I'll return a list containing the authority. The next method is getPassword. This method simply returns our password. Now, we have to get username, which returns the username. We have this method isAccount non-expired. It is true. isAccount non-locked is also true. In the credential non-expired, this also returns true. Finally, there's the isEnabled method, which returns the value of the enabled field. And that's all for the override methods. Now, we need to generate a couple of helper methods. First, I'll generate noArgs constructor. Generate constructor, select none. Now, I'll generate another constructor with all the fields except for ID. Generate constructor, select all. Except this ID. This ID field will be auto-generated. We do not need to include it in our constructor. Now, click OK. Let me put the parameters on new line for better readability. Now, I'll generate the getters and setters for all the fields. Generate, getter and setter, select all, OK. So, our user class is ready. Now, to interact with the database, we need a repository for this user entity. Inside the base package, create a new package, repository. Inside the repository package, a new Java class. Make sure you select interface, user repository. This repository interface extends from the CRUD repository. The CRUD repository is a generic interface, so I provide two parameters. The entity name for which we are defining the repository, user, and the data type of the primary key, which is long. Inside this repository, define a method to query the database by username. Since the user may or may not exist, the return type is optional. It returns user. Find by. This tells Spring Data JPA that we want to query the database based on the certain conditions. We want to find a username. Let's import the optional class. Import it from the Java UTL package. That's it. We do not need to write any database query here. Spring Data JPA is smart enough to generate the query based on this method name. It knows what we are trying to do and it will generate the database query based on this. If you want to know more about this Spring Data JPA, check out my Spring Data JPA crash course video where I explain it in detail. Back to the custom user details service. In this class, inject a user repository, adding user repository as private field, making it final. Now, we'll inject this with the constructor. Generate constructor, select the user repository. Click OK. Now, in this load user by username method, I am going to use this repository. In the return statement, user repository, calling find by username, pass the username. If the user is not found, throw username not found exception. We need to annotate this class with service annotation. Now, open the security config class. Here, we have defined this user details service bean that is used in memory user details service manager to store the user info. Now, we have defined our own custom user details service, which accesses the user data from the database. So, we do not need this bean anymore. Let's delete it. To use our custom user details service inside this security config, we need to inject it. Adding user details service as private field, custom user details service. Inject it using constructor. Now, in our security filter chain method, here we no longer have this user details service method. Replace it with our field. This is our user details service. Paste it. At this point, everything seems fine. Let's start the project. Process finished with exit code 1. That means failed to start. Let's check. Okay. I need to configure the application to connect with the database. Let's do this. I have already installed the PostgreSQL database in my local machine. Let's check. Here, my IntelliJ IDE comes with this database tool, which can be used as a GUI tool for the database. This is only available for the Ultimate Edition. Click this plus icon, then data source. My database is PostgreSQL. Here, my database is running on the default port. This default setting is fine for me. Here, I need to provide the username and my database password. Click on this test connection to check if everything works. It succeeded. Click OK. Now, we can use our IDE as a GUI tool for our database. Let's check the list of available databases. Here, this auth demo is the database for this project. Let's select it. Now, you can see it in the database list. Our auth demo is not showing any table. Let's fix it. Click on this label. From the list, check the public schema and refresh. Now, our public schema is available. Currently, the database is empty. We do not have any table or data yet. We are going to create it in a moment. Closing the database tool. Let's close this console tab. Here, we need to configure our Spring application to connect with the database. From resources, opening application.properties. Here in this file, I will provide the database configuration for our Spring Boot application. The first property is the database URL. Spring data source URL. Provide the database URL for the PostgreSQL. JDBC, PostgreSQL, localhost, port is 5432. Then the database name is auth_demo. Then the database username, it is Postgres password. Then we need the driver class name. Data source driver class name. This is warg.PostgreSQL driver. Then provide the type of the database we are using. That is PostgreSQL. Then we need to provide the database platform. That is warg, Hibernate, dialect, PostgreSQL dialect. That's all the properties we need to connect with the database. But beside these, I am going to define some other properties for my convenience. For example, I want to view the query in the console. So I am making show SQL to true. Then we need another property that is for showing the SQL query properly formatted. Spring JPA properties Hibernate format SQL. Set it to true. Then we need this DDL auto. Here we have couple of options. I am going with create drop. What it will do is that whenever we start the project, Spring Data JPA will create the necessary tables. When stopped, it will drop the tables along with the data. Thus, we will get a fresh database table every time we start the project. This option is only for the testing purposes. Never use this in production. To know more about this DDL auto property, please check my other video tutorial on Spring Data JPA. With this, let's start the project. This time, project ran successfully. Here in the console, you can see the SQL query printed. A new table named user has been created with the necessary columns that we have defined in our user entity. Close the console, back to the browser, refresh. Here we have the same login page. To log in, we need a user and password. But what is our username now? What is our password? We have configured our application to authenticate the user with the database. But at this time, we do not have any user data in the database. We just created a user table. We need a way to save the user to the database. We can do this by using a user registration form. The user will fill up the form and submit it. The user data will be saved to the database. A confirmation mail will send to the user's email address. When he verifies it, he will be able to log in using this form. Let's implement this. We need to define an endpoint for the registration form and form submission. Inside the controller package, create a new controller. Name it authentication controller. Annotate it with controller. I also need request mapping annotation for mapping register. Inside this class, adding get mapping, giving it a / public method, string name register. It accepts the model. Make sure this model is from Spring Framework UI. Create a new user instance. This user should be from our entity package. Then add a model attribute. The attribute name is user and provide the user and return the name of the HTML file. Another post mapping. This one is for processing form submission. Public string post user. It accepts the model attribute user, type user and model. Here we will save the user to the database. To save the user to the database, our controller will call custom user details service. The custom details service will perform the necessary validation and save the data to the database with the help of the user repository. Let's inject custom user details service here. Adding a private field, custom user details service. Inject it with constructor injection. Now we can use this service in this class. Here in the post user method, calling the user details service dot register user. We do not have this method yet. We will create it shortly. Provide the submitted user data. Let's move the method parameter to new line. Here, beside this parameter, I will add another parameter, redirect attributes. So, after the user is saved, we will call the redirect attribute and add a flash attribute. Name the attribute message and give it a message. Actually, after saving the user to the database, we will send a confirmation email. Here in the flash attribute, give it a message, please confirm your email address and redirect to register. Now let's create this register user method in the custom user details service class. Here in this method, we will query the database by username and email to check if the user with the same email address or username already exists. User repository. For this query, in our user repository, we need to create a new method. Let's open our user repository. Here, create a new method. Optional user find by username or email. Give username and email as method parameter. With this method, we are able to query and check the database if the user with the email address or username already exists. Now, in the custom user details service class, register user method, user repository, find by username or email. Provide the username and email. If user present, we will throw an exception. The user already exists. If the user with the username or email address does not exist, then save the user. But before saving, we need to encrypt the password. Creating a new variable password. We need to inject a password encoder. At the top of the class, new private field, password encoder. Inject it into the constructor, password encoder as a constructor parameter, and set the password in the constructor. Back to the register user method, password encoder, encode, provide the user submitted password, and save the user. Now, I will create a register HTML page. This HTML file will have the same HTML code and styles as our login page. Let's start the project. The project failed to start. There may be some kind of circular dependency issue happened. Let's check. The dependencies of some of the beans in the application context form a cycle. Here, two dependencies of security config and custom user details service forming a circular dependency. I think the password encoder causing the issue. Let's verify. Check the user details service, close the console. Here we have this password encoder injected. Check the security config. Here we also have the password encoder bean. Okay, what is happening here is that we have injected this custom user details service in the security config where the password encoder is injected. Again, the security config, we have defined a password encoder. So, what is happening is here that security config depends on a custom user details service. The custom user details service depends on a password encoder. This password encoder is also declared in security config. Since password encoder is not available until security config is fully initialized, this confuses Spring, especially during the bean initialization phase. This causing the circular dependency error. We can fix this by separating the password encoder into a different class. Inside a config package, create a new class, name password config. Annotate it with configuration. Back to the security config, cut the password encoder bean and paste it into the password config class. Now start the project. This time it started successfully. Opening browser, view page source, copy the HTML code, inside resources, template directory, create a new HTML file, register, paste the HTML. Here, we need to define TimeLeaf namespace. Update the style URL using TimeLeaf dialect. Replace the form method with the TimeLeaf dialect. Add th. Update the action URL. Th action. Then update the URL. Then we need th object attribute. Here, our object is user. We have this username field. This is the input field. We do not need this ID and name attribute. We will use TimeLeaf to generate it for us based on the object. Let's remove it. Then th field. Here, provide a field name. Let's use the field for the first name. Change label attribute to first name. Label text to first name. And placeholder to first name. Let's copy this portion of HTML code. Paste it below. Update it for the last name. Label text and placeholder last name. Again, paste the code below. Update the username. Label and placeholders are username. Again, paste. This is for email. The input type is email. Then we have this password. And finally, we need this CSRF input field. Update the name attribute to th name, and this is curly braces CSRF parameter name. This will dynamically generate the CSRF parameter name. Then th value. This is CSRF token, and update the button text to register. Now start the project. Our project has started. This is our login page. Let's browse our registration page. Register. It redirects back to the login page. We need to whitelist the registration endpoint in security configuration. So in the security config, this is our security filter chain method. Here we mentioned all requests must be authenticated. Here we need to whitelist the register URL. Request matchers. It's our register URL, and anything after this register, we need to permit all. Start the project again. Back to the browser. This time, try to access the register page. Same problem. Open the sidebar, closing the console. Here is our authentication controller. This is our request mapping. Register. We have this get mapping. Let's add a breakpoint here. Run the application in debugging mode by clicking on this bug icon at the top. Application started. Refresh the browser. Let's try to access the register page. No, nothing here. Stopping the server. Let's check the security config. It seems okay. Back to the authentication controller. Here we have this get mapping. We have provided a / as the endpoint. Let's try with this / in the URL. If we try to access the register, it redirects back to the login page. Here in our get method, we have /. So try with register, then /. This time it works. This is our registration page. There is this weird problem introduced in Spring Boot 3. Spring treats URL with a / at the end or without it as a different URLs. Let's update the get mapping, removing the /. Also, update the post mapping, removing the /. Back to the browser. Here is the registration form. We need to change the style of this email field. Open the register HTML file from the template. Here, this is our email field. Add style attribute. Give it height auto with 100%, font size to 1 rem, padding 0.5 rem, box sizing, border box. Now start the application. Navigate to register. This is our properly styled user registration form. Let's register a user. First name Iftikhar, last name Hussein. Giving my email address, giving a password. Register. It seems nothing happened. Actually, it is redirected to the same register URL. Here, we need to display the message in our register HTML at the top. After this heading, adding a new div. This will only be available if there is any message. Remember, we have added a flash attribute message in our post user method. Give here the name of the attribute and message. Give this div class alert and alert success. Inside this div, paragraph tag, the text of the paragraph will be the value of the message. Now again, start the project. Back to the browser, refresh, fill up the form. First name, last name, username, email, and giving the password and register. This time the form was submitted successfully and we have this message. Let's try to log in. Navigate to the login page, provide my username and password. Bad credential. Okay, let's check the data from the database. Opening the database tool, refresh. This is our public schema. Table. Our user table. Check the data. Here our user is saved but the password is not hash. Let's check. Navigate to our custom user details service. Here we are encrypting the password. However, we are not setting the user's password value. Let's do this. User.setPassword. With that, start the application again. Navigate to register. Provide the user information. Register. Registration was successful. Back to login. Provide the username and password. Sign in. This time, the error message is user is disabled. Let's check it in the database. Our database tool. This is our user table. Open the data. This time, hashed password is saved and here this enabled is false. Let's make it true. Now commit. Try to log in. Giving my credentials. This time, we are able to sign in. Now, let's implement email verification. The user will be disabled after registration. He needs to confirm his email to activate his account. Let's close the tabs. Here in our user details service, in register method, we are saving the user. After saving, we send an email with a validation link. That validation link contains a unique token. When the user clicks on that confirmation link, we check the token. If the token is valid, we enable the user's account. To generate the unique token, let's create a new Java class inside the entity package and name it token. Annotate this class with entity and table, giving it the table name confirmation_token. Now we need a primary key for this table. Let's copy the primary key definition from the user entity. Here is our user entity. I'll copy this ID block. Now I'll navigate back to the token class and paste it. Next, we need a token. Annotate with column, set the name to token and make it nullable to false. We also need the time when the token was created. Added a local datetime field called createdAt. Give it a column name and make nullable to false. Next, we define the expired time. Column name expires at and this also is not nullable. Finally, we need to know when the token is confirmed. Creating a column for this, naming it confirmed at. We do not need to make it nullable because initially it will be null. The value will be set after the user has confirmed the token. Private field, its local datetime, confirmed at. Next, we need a way to identify the user for which the token is generated. For this, we need a relationship with the user. One user can have many tokens. This is a many to one relationship. Use join column, set it to not nullable with the name user_ID. This will be the field name in the token table where it will store the ID of the user. And now generate the constructors. First, new args constructor. Then generate another constructor with all the fields except ID. Now generate getter and setters for all the fields. Let's create repository for this token entity. Inside the repository package, create a new interface called token repository. It extends CRUD repository with token as the entity and long as the primary key type. Add a method to find a token by its value. The return type is optional token. Find by token. Provide the token as the method parameter. Now I will create a service class to interact with this repository. Create a new Java class in the service package. Name it token service. Annotate with service. Inject the token repository with a private final field. Generate the constructor. Select the token repository. Define a public method findByToken. It returns the result from token repository.findByToken. We also need to import our token class from the entity package. Now add another method to save the token. It calls token repository.save. Back to the custom user details service. Instantiate a new token, confirmation token, new token, for token, generate a random UUID and convert it to string. Set the creation time to local date time. Now, the token will expire after 15 minutes. So, current time plus minutes 15. Finally, provide the user for which the token is created. My IDE is showing an error. Let's check the token class. Here, in the constructor, we do not need this confirmed add parameter when creating a new token. I'll remove it. Also, remove it from the constructor parameter. Back to the user service. I inject the token service. Defining token service as a private field, I need to inject it using the constructor. Let's move it to a new line. Provide token service as constructor parameter and set its value inside the constructor. Now scrolling down, here I save the token. After saving the token, we send an email to the user. For now, let's start the project. Here, a new table confirmation underscore token is created. Let's register a new user. Registration is successful. Now, let's check the database. Refresh it. This is the confirmation token table. Let's check the data. Here is our token. We have this expiration time and creation time. The confirmation at field is null, meaning the token is not confirmed yet. Check the creation time and expiration time. The token will expire 15 minutes after it has been created. And this is the token value. Now open the authentication controller. Here I need to add a new endpoint for token confirmation. It's a get mapping with the path confirm token. Define a public method that returns a string. It accepts the token as request parameter, which is of type string, and also accepts model. Inside this method, I call the custom user details service and confirm the token. I pass the token and return a new HTML page named confirm token. Let's create this HTML page. Inside the template folder, create a new HTML file named confirm token. Update the HTML title. Inside the body, add an h1 tag with the text email confirmed. Close this HTML. Here, we need to create this confirm token method in custom user details service. The method is created. Inside this method, I need to perform a couple of validations. First, I will check if the token is exist. Then, I will check if the user is already verified. And finally, I will validate if the token is expired. If everything is okay, I will update the confirmation time and enable the user. To check if the token exists, query the database by token. If the token is not found, throw a new exception, invalid token. Now, check if the user is already verified. If confirmed at is not null, it means the user has already verified the token. In that case, I throw an exception, user already verified. Next, check the expiration time. Save it in a separate variable, expires at. If expires at is before the current time, the token is expired. Throw an exception, expired token. If all the validation pass, enable the user and update the confirmation time to invalidate the token for future use. Set confirmed at to local date time dot now and save the token. Now enable the user, call enable user and pass confirm token dot get user. Now we need to create this enable user method. Here set enable to true and save the user. Scrolling up, here I'll send the email with the token. But before that, let's print the token. Now I'll run the project in the browser. Register a new user. Register. The registration is successful. Back to the IDE. Check the console. Here is our token value printed. Let's check if the confirmation works with this token. In the browser, the URL for confirmation is register/confirm token. We need a query parameter token. Here, paste our token. Email confirmed. Let's check the user table in the database. Here is our user table. Open it. The enable field is now true. Let's try to log in. Provide the username and password. Sign in. Login successful. Now it's time to implement the send email functionality. Create a new service class inside the service package. Name it email service. Add a service annotation. For sending email, we need to configure our application. Open application.properties. I will use Gmail as email provider. Set Spring Mail host to smtp.gmail.com. Set spring.mail.port to 587. Provide the username and password. Spring mail username. Here is my username. Then spring mail password. I need to generate an app password from Google. Open the browser and go to myaccount.google.com/app passwords. Verify my identity. Give this app a name. Create. Copy the generated password. Back to the IDE. Paste the password, removing the spaces. Now set the mail properties. Spring mail SMTP auth, set it to true. Next, spring mail SMTP start TLS enable, set it to true. In email service, create a private field JavaMailSender. Generate a constructor and set the value. Now create a send mail method. It accepts two parameters, the recipient's email and the token. Wrap it in a try-catch block. Print the stack trace if there's an exception. Instantiate a simple mail message. Set the recipient, sender, this is my email address, subject, add message body. Then we need a message body. In the message body, add some greetings and provide the confirmation URL with the token as a query parameter. Localhost 8080, register, confirm token and string placeholder, and use the formatted method and provide the token. Set this message body as the message text. Finally, send. Make this method async so it does not block the execution. Also, we need to enable async. Open authentication application class that contains our main method. Here, provide annotation. Enable async. Back to custom user details service. I add a private field for email service. Inject it through the constructor. Provide it as constructor parameter. Inside the constructor, set the value of the email service. Scrolling down, here I send the email service.send user.getEmail and pass the token. Restart the project. Register a new user. Registration is successful, but there's an error in the console. Authentication failed. Open application.properties. I need to provide my full email address as the username. Restart the project again. Register a new user. This time, no error in the console. Check the email. Here is the confirmation email with the token. Click the confirmation link. It redirects to the login page. It should display our confirmation message. Maybe there is some error in the URL. Let's check. Confirm token. The query parameter is missing. Let's fix it. Open email service. Here this is the link. Add the token query parameter. Restart the project. Register a new user. Now let's verify it in the database. First, open our user data. This is disabled and confirm token table. We have this token and confirmation time is null. Now check our email. Here's the new email with the correct link. Close the other tabs. Click the link. Email confirmed. Check again the database. Refresh the user data. The user is now enabled. Check the token. We now have this confirmed time. Now try to log in. Go to the login page. Provide the username and password. Login. Login successful. One small update. Opening register.html file. Here, change this form heading from sign in to sign up. And that's it. We have successfully built a secure user registration system with Spring Boot, from setting up the project and securing it with Spring Security to adding email verification and database integration. Now, here's a little task for you. When registering a new user, we have saved the email address directly into the database. Your challenge is to validate the email before saving it. Try it out and share your solution in the comments. I hope you found this tutorial helpful. Don't forget to like, share and subscribe for more step-by-step guides. I'll see you in the next video. Until then, happy coding!